Now for something a little different. So I'm Aaron Hirsch. I'm with the Minnesota Geological Survey. We were founded in 1872 as part of the research and the research arm of the Earth and Environmental Science Department. We're about 30, 40 folks. I just wanted to kind of we saw this as a group and like this might be something that we are not experts in, but maybe someone else might be an expert and could utilize some of the stuff that we do. So we are, as part of our directive, we are provide stewardship of land, water, and mineral resources, and we do this through systematic geoscience information. Specifically, right now we do what's called County Geologic Atlas Program, and we go county by county, usually working on many at one time. And we generate this geoscience information in terms of databases, geologic maps, whether it's bedrock geology, superficial geology, well data, things of that nature. And then we provide those to the counties for a lot of well planning and general county services. Just for reference, we have our websites down at the bottom here. The top one there is just kind of about us, and then the bottom one has a lot of our databases. And so the one thing I do know about it's the laptop. Yeah. Laptop, there we go. One thing I do know about generative AI is it requires large data sets, and that's one thing that we do have. So here's just a small smattering of our data. So we have hundreds of thousands of data points of aeromagnetic data, over 50,000 gravity measurements across the state of Minnesota, over 10,000 borehole geophysics measurements, so measuring geophysical properties of the rock as it goes down through the hole in the ground, structural data measurements of dip and strike of different rock formations. Probably our largest data set, we have over 400,000 unique well locations with hundreds of thousands of geology and geophysical attributes. We have 10,000 plus petrophysical data, so rock properties, along with hundreds of different geologic maps of various scales and regions. And so we also have many other data sets, whether it's the thousands and thousands of grain counts for the unconsolidated sediments that you see at the surface, our lithostratigraphy, radiometric data, MGS. So this is more of a call to like, if someone was interested in geospatial data sets, we have, at least in Minnesota, some of the most well-established and largest data sets that you can find in terms of a state survey that can be utilized in terms of generative AI. And so to kind of end with kind of a call to action, but also with a warning, I kind of just threw up some of the things that I briefly read about at maybe potential opportunities for generative AI to work with us at the MGS, whether it's just using it for large training data sets, modeling, so doing actual geologic mapping with generative AI, utilizing what we already have, interpreting legacy data, rock descriptions, predicting if we're going to drill in a hole, predicting what's actually going to be in that location, whether it's, and not just what's in the hole, but how deep could that hole be, potential aquifers, mineral resources. And if we know the geology of a hole, can we then say, what would that look like in terms of a borehole geophysical log? Or we have a borehole geophysical log, what does the geology look like? Interrogating our lithostratigraphy from grain samples and several others. So lots of possibilities. These are things that I thought of. I'm no expert, so there probably are many more. But with that, there's also the warning. I read this recently in a 2024 paper. Geoscience phenomena are generally multivariate, nonlinear, chaotic, have non-stationary properties, and contain unusual but fascinating events. So really interesting stuff, but also extremely difficult to work with. And so with that, thank you.
Yeah. Let me ask a question. So you have such huge data set. I think that's a really big advantage over others. But my question is, what is the first priority? What's the most important problem to try to solve in your field with generative AI or whatever?
Yeah. So just in general, we have all these drill hole locations, but we also have lots of areas where we don't have drill hole locations, and then we're relying on geophysical data. How accurate is the geophysical data where we don't have geologic data? To us, like that's where our unknowns are. So providing that information, we make our best first guess and we present it as fact. Whether that's fact or fiction, we won't know until we actually drill a hole there and can then prove that point. So there's no way a single person's going to be able to go through hundreds of thousands of data points to systematically go, this is your best guess. They'll use their general knowledge from, I've worked at the survey for 10 plus years. This is what we think it's going to be, but we're shocked all the time. We're like, oh, everything down here is very normal and planar. We discovered what's possibly an ancient impact crater that happened 300 million years ago or so. So lots of things that are interesting.
So let me paraphrase the question.
Yeah.
So it's one thing to do mapping, and you are doing 3D mapping, which is great. But the question is, who is going to use that data? For example,
Right.
your mining companies, right? Petroleum, Schlumberger, and all do the same thing. They poke holes. Say,
Yep.
Did I find oil here? I did not. Where should I poke the next hole? And to do that, they have to have some 3D map of the underlying stuff.
Correct.
So, and water quality people may worry about it, right? The question is, who are your real, key end users of your 3D maps?
Right. So it's the whole spectrum, whether it's academia. We work a lot with the department in terms of just general research of the earth. It's also city planners. It is working with MPCA, so the Pollution Control Agency, Department of Health, so government agencies, but also NGOs, lots of people, and then also all of the industry folks as well. So it's the whole gamut of folks use our data, and they all kind of pick and choose the data sets that they want to use. It depends on what they're interested in. So we have to try and make everybody happy.
I think it sounds like just resonating with others here. It sounds like if you can come up with a person or people who can ask a specific question within their domain field that could use this data set, then you and that person and maybe some of the computer science experts here could form a team, for example, to go after it.
Right.
Yeah. I think that's what it boils down.
I actually have a question. Can you use that radon levels?
Not radon levels per se, but the radiometric data gives you at least a superficial estimate of uranium, thorium, and potassium
Okay.
estimates. So, but very near surface, like within the top foot of the.
Okay. But I'm asking this because it's a huge public health.
Right.
And
Yeah.
Today you just, it's hard. You have to with this test in your house.
Yep. Yeah.
And so if you had a map for these people who know, okay, I'm at a high risk region, and I'm sure
Right.
some counts.
Yeah. And there's certain data sets that we don't like collect ourselves within at the survey. I'm not sure if like a lot of those tests then go to a centralized database, maybe at MDH, or it's just they do one off and that just disappears, and there's now that data's scattered throughout the ether.
Maybe use petrophysics or something
Right.
to inform that, or some combination of others.
Yeah.
Another question.
Yeah.
I'm curious about what is the resolution of the map data set?
The geologic maps.
Right.
It all depends on the scale. So if you're looking like very broad, you can look at 1 to 100,000 or 1 to 250,000. You can zoom in to 1 to 24,000. And that's about the closest resolution that we usually do, because most of Minnesota, I didn't talk about it, but most of Minnesota is covered by glacial sediments. So this is our bedrock geology map, which means most of this we interpreted based on drill holes and our geophysical data. And so there's only so much resolution. You can't get so fine a scale when you have a couple hundred feet of sand on top of it.
I do have an example. I'm working on predictive geoscience. Particular project is about the groundwater modeling and how to reconstruct the subsurface fracture system like in the Cascade
Okay.
aquifer. So I'm just curious, for example, the borehole you are mentioned here, but the real data I really need is the under the ground, some trace data or some like a hydraulic pressure data, whether you also have this kind of data.
We do have some like hydrology and like flow data. I would say the vast majority of that's going to be kind of southeast here, where we have most of the aquifers are in sandstones. Versus if you go outside of that, most of the uppers are in unconsolidated like sand bodies that are within the subsurface. But yeah, we have that flow data. You utilize it mostly with working with like MPCA, for example, forever chemicals and Woodbury. We participate in that kind of projects.
Right. Wonderful. So one thing I do want to mention, and again, you may have to go a little national for that, but AI in geosciences was a program in NSF, and I believe it was still around till the shutdown.
Yeah.
So, yeah, geosciences is very gung ho on data, big data and AI and so on. So it may be worth starting.
Yeah.
But probably, I agree.
Yeah, like we do a lot with big data. It's more the brute force aspects of brute data.
Right. But hopefully you can do better than kriging, right? Which is
Right.
what mining people did for 100 years, right?
Right.
So maybe as they're trying some new AI and generative model.
Mhm. One more question, and then we should wrap it up.
So you also have this as a time series. So for example, for some borehole, for the same location, like, how many samples do you have, or what's
Right.
the time gap between the data points?
So we do, but it's not as many as would be super significant because we're mapping throughout the state. So once we map a county, we kind of move on to the next county. Every once in a while, we'll come back to that county, or for special projects, we'll have certain boreholes that we continually look at and monitor. For the most part, people that are doing the monitoring themselves are going to be like the pollution control and MDH, and even the DNR. They do more of the monitoring of the wells. We'll kind of take our samples, and we're just kind of getting into that world where measuring water samples and coming back.
Would it be useful if we can predict like what's changing in between those two measurements?
Oh, absolutely. Yeah, especially if you're looking at like plumes and contaminations in the subsurface. We have this data point, we have this data point, being able to not only predict what happened between them, but then maybe what's also going to happen in the future.
And one other question maybe later on we can ask, but is your department or other state agencies, are they investing in this AI, Gen AI approaches? Are they also seeding collaborations with cross sectors?
I can't speak for like the DNR or MPCA or MDH, but we're in our very infancy, just starting to work in AI itself. We just started looking at can we identify different rock minerals based on just images, and then being able to speed up some of those kind of workflow.
Okay.
That's like our first step.
Wonderful. It will be good to talk afterwards, LCCMR and those vehicles. I don't know if your agency goes through
Yep.
that. And
Yeah. Oh, yeah.
Do you think it's suitable for them?
Excellent, start.
Right? Yeah, it will be good for us to help develop that.
I think we have to wrap up. Thank you very much, Aaron, and everyone else today.